Hi folks, welcome to your very first set of ICP video notes. Today we're going to be covering the different ways to measure basic motion. Go ahead and take a moment to write these vocabulary words down. They will come in handy later. So the first thing we're going to talk about are scalar versus vector quantities. These are the two types of quantities or measurements that we'll use in this classroom. Scalar quantities are those measurements that only have a magnitude or a number with a unit. For example, speed is a scalar quantity because we measure it as, for instance, 55 miles per hour. Some other scalar quantities could include distance or length. Vector quantities, on the other hand, are those measurements which have a magnitude and a direction. These are often specific to a physics classroom and not something you'd often hear in daily life. One example is velocity. If I were driving down State Road 9 coming from Marion to Madison Grant, I might say that I was going 55 miles per hour to the south. Saying to the south turns the 55 mile per hour scalar quantity into a vector quantity because now it has a direction. Some other examples of vector quantities are displacement and trajectory. There are two types of calculations for length of a travel. The first one is distance. When we calculate distance that something travels, we have to look at the path that object takes. This is why we call distance a path-dependent quantity. The easiest way to calculate the distance traveled is to break the trip up into smaller segments. Measure each of those segments and then add them all up. This will give you the total distance traveled for an object. Since distance only includes a length and no direction, it is a scalar quantity. Now, when calculating an object's displacement, you only look at where it started and where it ended up. You don't have to worry about the path it took to get from point A to point B. So we call it a non-path dependent quantity. In this case, you would measure a straight line from start to finish. Once you get that measurement, you also have to specify which direction that object traveled. Since displacement includes both a length and a direction, it's considered a vector quantity. So if I started here at point A and traveled around as I pleased and marked my path as I traveled, you could then see the path that I took. If you want to calculate the distance I traveled, we would break my path into smaller segments of straight lines. We could measure those segments and then add them all up. My first segment takes me 2 blocks to the north, and then I go 1 block east, 1 block south, and finally 1 block west. That gives us a total of 1, 2, 3, 4, 5 blocks. If we were to measure my displacement, we would only look at where I started and where I finished. We can forget that I went around in a circle and pretend that I just went from point A to point B. This is a length of 1 block and it goes directly north. So my displacement would be 1 block to the north. Now, in order to calculate speed, you need that distance that's traveled, which again is path dependent, and the time that it took to travel that whole distance. An easy way to remember the speed equation is if you take a distance raptor and divide it by the time raptor, then you get the velociraptor. So our three variables in this equation are speed, distance, and time. If you have any two of these variables, you can find the third by using one of the equations to my right. If you're looking for speed, use the first equation, s equals d over t. If you're looking for distance, use the second equation, d equals s times t. And if you're looking for time, use the third equation, which is t equals d over s. Now, velocity isn't really much different than speed. The calculation is exactly the same, but in order to be considered velocity, which is a vector quantity, we have to include the direction that the object traveled from start to finish. This would be the same direction you'd find for the object's displacement. Alright, so let's take that same path that I traveled before, assume that each block is 100 meters long, and also pretend that time's going much faster than normal. So let's pull up our handy-dandy stopwatch and see how long it takes me to travel this path. Okay, it seems like it took about 250 seconds for me to travel that path. If you remember, we calculated earlier that I traveled 5 blocks. If each block is 100 meters, then how many meters did I travel? This is where our unit conversion process from earlier comes in handy. So let's try it. First, we write down the 5 blocks that we know. Our conversion factor is that 1 block equals 100 meters. So we plug that in and get 5 times 100 equals 500 meters. Notice that the blocks unit cancels out. Now, since we're looking for speed, we'll use the s equals d over t equation, take our distance, which is 500 meters, divided by our time, which is 250 seconds. And we find that I had an average speed of 2 meters per second. If we wanted to find the velocity, we'd just take that speed that we just found and add our direction from start to finish. So our velocity would be 2 meters per second to the north. Well, folks, you did it! Whew, that was it. That's it for this set of video notes. I hope that you were able to soak up some of the knowledge about the different ways of measuring basic motion. And as always, if you have any questions, please feel free to ask me.